This is Algebra Lesson 9-4, multiplying special cases. We're going to do a little bit of review here. And this is just multiplication of binomials. And so if you distribute it, you can solve these fairly quickly. So we're going to multiply these fairly quickly and see if we can figure something out within the process. If I distribute, I will have x times x plus 8 times x plus 8, which gives me x squared plus 8x plus 8x plus 64, which is x squared plus 16x plus 64. That's the final answer for that one. We look at y plus 5 times y plus 5, and y parentheses y plus 5 plus 5 parentheses y plus 5. So y squared plus 5y plus 5y plus 25. So y squared plus 10y plus 25. Okay. If I have 2p plus 3 times 2p plus 3, we have 2p parentheses 2p plus 3 plus 3 parentheses 2p plus 3. So we're going to end up with 4p squared plus 12p, that's 6p, excuse me, I can multiply, plus 6p plus 6p plus 9, which makes this 4p squared plus 12p plus 9. Now let's look at some with subtraction. We do d minus 3 times d minus 3, we're going to have d parentheses d minus 3 parentheses d minus 3. So that gives us d squared minus 3d minus 3d plus 9, which is d squared minus 6d plus 9. T minus 1 times t minus 1 is t parentheses t minus 1 minus 1 parentheses t minus 1. T squared minus t plus 1, so t squared minus 2t plus 1. And last but not least, if we have 9r minus 2 times 9r minus 2, 9r parentheses 9r minus 2 parentheses 9r minus 2. That gives us 81r squared minus 18r plus 4. 81r squared minus 18 and 18 is 36, 36r plus 4. Now let's take a look at this for just a second. Do we notice any patterns of any type? I automatically recognize a pattern. I know these are both binomials. Okay, x plus 8 are binomials. These happen to be a binomial basically multiplied by itself. Because I have, if we look here carefully, we have x plus 8 multiplied by x plus 8. It's basically multiplied by itself. 2p plus 3 multiplied by 2p plus 3. 9r minus 2 multiplied by 9r minus 2. That's called squaring a binomial. It's the binomial squared. We could write that simply. For example, the 9r minus 2 could be rewritten as 9r minus 2 quantity squared. This means the exact same thing as that right there, multiplied together. Now, once you multiplied, okay, and found the product, we should see some sort of a pattern here. Okay, I'm hoping that you're looking at this going, wait a second here. If I look really, really closely, I notice that if I take my first term, d, and I square it, I get that. If I take my last term, negative 3, and I square negative 3, I get 9. And if I look at it and go, how does this middle term relate? Well, if I multiply the 3 and the b that is right here, multiply that by 2, I get negative 6b. So this is a square, b squared, this is a square, 3 squared, and this is the middle. This is 2 times the b and the 3. Right? And if you look at all of these, you might hopefully notice that they all kind of do that. Let's take a look at this one right here. 2p plus 3, 2p plus 3. Okay, 2p squared is 4p squared, which is that. 3 squared is 9, which is that. If I took 2p and 3 and multiplied them together, 2p times 3, I would get 6p, and if I multiplied that by 2, I would get 12p. So what this leads us to is some special products. And once we multiplied, did we notice any patterns? Well, yeah, hopefully you noticed a pattern, and what you should find out is this becomes what we call multiplying special cases. The square of a binomial, if I have a plus b quantity squared, a plus b quantity squared means a plus b times a plus b. When we multiply it out, we get a squared plus 2ab plus b squared. If it's a minus, a minus b quantity squared, you get a minus b times a minus b. The only thing that changes is the sign right there. The square of a binomial is the square of the first term plus twice the product of the two terms plus the square of the last term. If you don't understand how to multiply by the special cases using these special formulas, you can always multiply using the distributive property and get the correct answer. Eventually, however, you'll learn these special properties and it will speed up your multiplication. For instance, I can tell you right now that the answer of t plus 6 quantity squared is t squared plus 12t plus 36 without having to do any of those little steps. Okay? Without having to write out t plus 6 times t plus 6 and getting t squared plus 16 plus 16 plus 36 and then simplifying it. The reason being is because I see that this is a binomial square. My a term is t, my b term is 6. It's a plus, so we're going to use this formula right here, the a squared plus 2ab plus b squared. A squared plus 2ab plus b squared. That's the formula I'm going to use. It tells me to take a and square it. So my a term is t. I'm going to square it. And it says add 2 times my a term, which is t, times my b term, which is 6. And then it tells me to take my b term, which is 6, and square it. So I get t squared plus 6 times 2 is 12t plus 6 squared is 36. That's how I got to this answer right here so quickly. Right, that's how I got to that answer so quickly. Now I'm going to erase a few things just because I've worked in my next problem and I need to have some space to be able to work here. So I'm going to erase this at the moment. Hopefully you got that. Let's look at this next problem. Again, it's an a plus b quantity squared, isn't it? Because I have an a and a b and the square term right there. It's the same thing. So it's an a plus b quantity squared. So my a term is 5y and my b term is 1. So if I follow this formula right here, it tells me to take my a term, which is 5y, and square it, plus 2 times my a term, which is 5y, times my b term, which is 1, plus my b term, which is 1, and square that. So 5y quantity squared is 25y squared. Remember the properties of exponents we learned in chapter 8. Plus 2 times 5 is 10, times 1 is 10, so I have 10y. 1 squared is 1. There we go, I am done. I can save myself lots and lots of time if I learn these special products. Okay, it's a subtraction problem. Okay, now we have subtraction, so we know this is going to be a squared minus 2ab plus b squared. Okay, now we're using this formula right here. So it's an a minus b quantity squared. So my a term here is 7m, and my b term is 2p. It's not negative 2p because the fact that the subtraction sign is taken care of in the formula. So if I follow this, it says a squared, which is 7m quantity squared, minus 2 times a, which is 7m, times b, which is 2p, plus b squared, which is 2p quantity squared. So now I do the math. 7 squared is 49. This becomes 49m squared. 7 times 2 is 14. 14 times 2 is 28, minus 28mp. I like to do the variables in alphabetical order. Plus 2p quantity squared is 4p squared. And there's your answer. I'm going to just give myself a little bit more room to do 4. I'm going to do 4 down here so that I have a bit more space to work with. 9c minus 8 quantity squared. Again, it's a subtraction problem. So for subtraction, it's going to be a squared minus 2ab plus b squared. My a term is 9c, and my b term is 8. So I'm simply going to follow the formula. It says to take a and square it. So 9c quantity squared. And it says minus 2 times my a term, which is 9c, times my b term, which is 8, plus my b term, which is 8, and square it. So multiply that out. 9c quantity squared is 81c squared. Okay, 9 times 8 is 72. 72 times 2 is 144. So I have 144c plus 8 squared is 64. Now, if you don't understand how to use these special products, you can always multiply it out. I can multiply 9c minus 8 times 9c minus 8. I have 9c parentheses 9c minus 8 parentheses 9c minus 8. I get 81c squared minus 72c minus 72c plus 64. So I have 81c squared minus 144c plus 64. The reason I like the special products is eventually you'll be able to go from here to here without having to do any of the middle terms whatsoever. And it will speed up your multiplication. If you don't understand the special products, stick with the distributive property. It works every single time, 100% of the time. It's just a little slower sometimes, and that's okay. It can be slower. Okay, let's take a look at something else. What happens if we have the sum and the difference? And notice before we had a plus 2 times a plus 2. Here we have a plus 2 times a minus 2. Let's distribute and find out what happens. We have a parentheses a minus 2 plus 2 parentheses a minus 2. We will get a squared minus 2a plus 2a minus 4. So we get, oh look, these two cancel out, and one's a plus and one's a minus. A squared minus 4. We have 2x plus 3 times the quantity 2x minus 3. That gives me 2x parentheses 2x minus 3 plus 3 parentheses 2x minus 3. So that gives me 4x squared minus 6x plus 6x minus 9. Again, the term cancels out. 4x squared minus 9. If I get an a plus 8 times an a minus 8, I get a parentheses a minus 8 plus 8 parentheses a minus 8. So that gives me a squared minus 8a plus 8a minus 64. My middle terms cancel out, so a squared minus 64. You'll notice that in every single one of these, we have no middle term whatsoever. They cancel out every single time. We had a plus 6x, a minus 6x, a plus 2a, a minus 2a, a plus 8a, a minus 8a, which means they canceled out, which means we're left with our first term squared minus our last term squared, which is another special product. Okay? This is called the difference of squares. Okay? The middle terms are additive inverses of each other, thus cancel each other out, leaving a squared minus b squared. That's the difference of squares. Why I wrote this twice, I have no idea. Don't worry about this, because it's right above it. I just wanted to make sure you really understood that, so I wrote it twice. Okay, that leads us to this second special product, the difference of squares. A plus b times a minus b is a squared minus b squared. And you can speed up your multiplication immensely if you understand these special products. So if we look at these examples, let's say we're going to find the product of d plus 11 times d minus 11. My a term is d, and my b term is 11. So I'm going to do a squared minus my b term squared. So I'm going to have d squared minus 121. Pretty simple. Here, my a term is 9b to the third. My b term is w to the fourth. So I'm going to take my a term, 9b to the third, and I'm going to square it. And I'm going to subtract my b term, which is w to the fourth, and I'm going to square it. So 9 squared is 81. B to the third raised to the second is actually b to the sixth. Remember, power to the powers multiply. Minus w to the fourth power raised to the second power is w to the eighth power. I'm done. So much faster than actually multiplying it out using the distributive property. And last but not least, my a term on problem number 3. My a term is c squared. My b term is 8. So I will have a, which is c squared, quantity squared, minus my b term, quantity squared. So c to the fourth minus 64. You can save yourself an immense amount of time if you learn these special products. Okay? These special products are also very helpful when dealing with mental math. If I had to square 51 squared, I can't do that really super fast in my head unless I think about this. 51 is the same thing as saying 50 plus 1. Right? So I can do, 50 plus 1 quantity squared, right? So that would be a 50 squared plus 2 times 50 times 1 plus my b term squared. That's 2,500 plus 100 plus 1. 2,601. You're like, how's that mental math? You wrote a whole bunch of stuff down. Eventually you'll be able to do it in your head. Right? Let's think of 43 times 37. You might go, how in the world is that supposed to be helpful? Well, I think of 43 as being 40 plus 3, and 37 as being 40 minus 3. So 43, to me, is 40 plus 3, and 37 is 40 minus 3. So that gives me 40 plus 3 times 40 minus 3, which means it's an a squared plus b squared. A plus b times a minus b, which is an a squared minus b squared. So that gives me a 40 squared minus b 3 squared. Okay, 4 squared is 16. Add 2 zeros to get 1,600 minus 9. 1,600 minus 9 is 1,591. Okay, mental math. Even though you had to use a little paper pencil, it's still faster than multiplying 43 times 37 the long way. And eventually you'll be able to do that in your head and impress all your friends. Okay. If you don't understand how to do the special products, try them. The more you do the math, the better you'll get, and eventually, if you use the distributive property all the way through the assignment, and you'll get the right answers, and eventually you'll start to pick up the pattern, and eventually you'll just be able to do the special products without having to multiply long way.